All right, everybody. Welcome. Get transitioned over. Um, let's talk about kind of what we're looking at here. I'm gonna turn down the volume just a little bit, guys. Um, but we are looking at an interesting logic puzzle game. Um, I watched somebody play it for like 10 minutes last night, and I was like, "Oh, that looks cool." Very much scratches a programmer itch. Let's give it a shot. And it's this game called Bombe, I think it's pronounced. I don't know. Bombe is how it's spelled. Um, I just went in and reset everything. I played through like the first 100 levels. You guys will see that's not a lot. Main reason why we're gonna be playing a game tonight is I'm deep in code at work, and I just want a break. uh, I didn't have a lot of time to plan for the stream tonight, but um, this looks like it will scratch an itch. Looks like something that'll be a good break. Anyway, it works really interesting. It's basically you create logic to solve Minesweeper puzzles. So if you guys know how to play Minesweeper, right, you've got the number here. It tells you how many adjacent bombs you're touching based on the shape, right? The interesting thing about Bombe is it starts out fairly simple. It gets more and more complicated. This is a typical Minesweeper. The levels I played through last night were using the hex shape. And so, you've got 8, right? Is that? No, it's 6. 6 touching, and then, the center. Here, with this, you've got, what is that, 8 touching? Here, we've got a whole bunch more touching. And the game kind of teaches you how to play it, but it also is a little bit, it can be a little bit difficult at times. To understand how it works. And so, we'll learn it together. How many is this? Ends up being 2, 4, 5. There's 9, 10, 12. So 12. So 6, 8, and then 12. I don't know if it gets more complicated than this or anything like that. I've only ever seen, like I said, the first 100 levels, and they're all hexes. But you'll see how quickly you go through levels. So yeah. Yeah, Michael, definitely a bit too burned out from coding at work to do more than games tonight either. Well, that's great. We can do some logic gaming together, right? These kind of games, I love them because they keep my mind sharp. And I don't know, but I'm like I enjoy bigger games like Baldur's Gate's a lot of fun. I've played a lot of the Assassin's Creed. I haven't played the newest one, and I don't think I'll get the one that's coming out soon either. I don't know. Like Red Dead Redemption was a lot of fun. Grand Theft Auto and Saints Row are always something that I'm, if I'm in a bad mood, those are always a good time. So, I'll play some of the newer games, but I really like indie games like this, like factory games, and things like that. So, like, I don't know, we were talking about Shapes 2 coming out, right? And the new Factorio and stuff. This one really scratches that itch. So these, as we play, these areas wind up being known as regions. And you can see that, they've selected a region and they've said, hey, if there are exactly 3 touching a number 3, there has to be 3 bombs, right? So you know that there are 3 bombs here. And so if you select the bomb, then it's going to mark everything as bombs. If you select mark all clear, then it's going to mark everything as clear. There are other rules you can perform, and like this one's saying, you know, it doesn't matter how many zeros are touching a square, that's always going to be clear. That's basically what this question mark says. We won't even have the question mark in the very beginning. And these are all of the, this is all of the instructions, and then you're dumped straight in, and it's, you know, it's having me double click here, then double click here, and now we're going to create a rule, right? And so we've double clicked here. Here's our rule. We want to say, hey, if there's a 0 touching a 1, we know it's safe. So we're good. Definitely let me know if the music's too loud, right? But anyway, we're on to the next rule. Again, we've got some zeros touching a 2 here. And we're going to clean these up eventually, but because zeros are touching a number, we know we're good. And so now we've got like the classic 1-2 rule here, but we've also got another easy one. If there's a 1 sitting by itself, we know it has to be a bomb. Boom. So that one solves it. But we've got the classic 1-2 rule, right? Where we've got 2 items. You know, there has to be 2 bombs. Well, actually, we don't even have to do this one. Because we know for a fact that there are 2 bombs sitting in 2 squares. They have to be bombs, right? That's our logic. There we go. Now we've solved the first puzzle. We're on to the next puzzle. And music is at a decent level. Thank you, Michael. Now we're on to the next puzzle. Right here we can see, hey, we've got 4 items touching this. This is my only complaint with this game, is that sometimes it can get really difficult to see what's going on. But here we've got 4 items touching a 4, and 3 touching a 3. I'm gonna pick the 4, right? We know these all have to be bombs because it's 4. There have to be 4 bombs in 4 squares. We know they're all bombs. Boom. We're good. And notice that the 3 went away. And the other thing is it's slowly animating things, right? It's moving very, very slowly through the rules that we've set up. And so far, you know, we're at a good place. But hey, you know, we solved enough puzzles, we can speed things up a little bit. So let's go a little bit faster, right? Now we're playing at normal speed. Here it's saying, hey, we've got zeros touching another number. Great, we know that's clear. Boom, we can move on. And now that, right, it goes much faster. And maybe I'll slow it down just a little bit so that, you know, you guys can get kind of an idea of what's going on. But again, we've got 3 potential bombs touching a number 3. We know this has to be a bomb. And this, like, the UI takes a little bit to get used to, but once you know how it works, I actually find it to be a lot of fun. We're gonna go a little bit faster. So now that we're, you know, now that we've made it through more levels, we can see our rules. And I really like that. I typically sort them by bottom down, but sometimes I'll swap the sort order to be top to bottom. So we can see that, like, our 0, right? A 0 touching a 1 has cleared 13 cells for us, right? A 1 touching a bomb has cleared 12. A 0 touching a 2 has cleared 20. So we can see, you know, how many cells our rules are and how many times our rules have been activated. I imagine that'll be useful in the future. I don't, right? But we know there has to be a bomb because it's a 5 touching a 5, so there we go. And again, right, it's playing on for us. So we aren't playing the Minesweeper. What we're doing is we're solving the puzzles, right? So the number of cells can be set to don't care, which I love, right? And then, you know, we can have up to 4 regions joined together now. Well, we always could, I believe. But so here we go. It's not telling us, hey, don't care, right? I don't know why it wants us to use a don't care here. What I do want to do is I want to go in and look at these rules that have zeros in them. We're going to edit this one, and we're just going to say, hey, we're going to change that one to a don't care. And we're going to update this rule. And then what we can do is we can go in and delete all of these other rules. And so now this rule, it's, you know, this rule will hit all of those other rules and we won't have to recreate them. So that was one thing I figured out. I don't know if there's a limit on rules. I haven't done anything with it yet. So we know we've got 5 out of 6 and 1 out of 1. Oh, I see what's going on here. So if we look at the logic here, within these 4, there has to be 1, right? We also know that there has to be 5 here. So if we count this out, we've got 1, 2, 3, and then 4 outside of this area. Well, and it gives it to us, right? So these 4 we know have to be bombs. We also know that this has to have 1 and these can be 0. What we can do is we can say, hey, we don't care about this number, but we know that it has to be clear, right? And the reason we know that, again, is like logical deduction, right? We've got 4 here, so there has to be at least 1 in these 2 squares. This is also part of a region that has to have 1 in it, exactly 1. So we know that there can't be any in however many aren't a part of these pairings right here, right? This is our logic. We hit OK, and it works, right? And it moves on. And I'm going to speed it up just a little bit, because it's the puzzles that are interesting to solve. It's not like the game itself is, solving these puzzles. And now it's telling us about some new controls we're going to get. So if we put a 6 in, it means that's exactly 6. This means that, it's greater than or equal to 2. This is less than or equal to 5. This means that it can't be the number 4. This means it has to be either 4 or 6, 3, 5, or 7. And then this one's a little bit weird because it's odd numbers. I'm not sure how this works. So we'll have to experiment with this one. I didn't see the odd numbers as we were going through. So I'm not really sure about this one. Actually, I didn't see any of this from here down, I think. Because I was doing fairly simple puzzles early on. And that's why I'm going a little bit faster. Okay, we have an interesting situation here. Where we've got to figure out what this means, right? We've got 3 1s here, which means if we look, we can have a 1 here, a 1 here, right? A 1 could be here, or a 1 could be here or here, which means, if we have a 1 here, we can't have 1s here or here. And so we need to come up with a rule that it can use to break things down. So let's see if we can cut some of this stuff out. It looks like if we bring this in, and here's the new controls, right? That's one of the things that I like about this game, is that it slowly introduces new stuff to us. So here, and here, and it took me a while to get used to this. So within this region, this box right here, these are the 2 squares, right? So we know there has to be a 1 here or here. Also, within this bigger region, there has to be a 1 here, here, or here, and there has to be a 1 here or here. So let's see if we can figure out some logic that will allow us to determine where the 1 should be. And actually, we don't even need to go this far. I can see something that will help us. If we take this, we know there can't be 1 here. And the reason we know there can't be one here is that there has to be one here or here, and these overlap, right? So we know for a fact this has to be clear. So if we clear that, then our other rules solve it, right? So now we're running into a new situation, and this is kind of the Zen stuff that I like about what we're doing. It's very logic based, right? And so it scratches that programmer, I need to solve a puzzle part of me, but it's also very I don't know. I don't have to really. I'm more. It's like working in code, right? When I look at these rules read kind of like code to me once I understand them, right? So like this rule means that anything touching a 0 has to be clear, right? Very much code, as far as I'm concerned. So it's very much a programmer game. This isn't going to help us at all, right? This is a 50-50. We don't know anything about it. What we do know is that if we group this and we group this, this has to be at least one here or here, which means there has to be a bomb here, and this has to be clear. How would we go about saying that? So that has to be clear, and that, okay. Well, it looks like it's either or. I would prefer to like kind of narrow things down. So let's see what happens if I do this, and that clears it up, right? So it was able to solve it by me making the puzzle smaller. And again, I don't know how complicated these get, but let's start with the biggest. So we've got, there has to be at least 3 within 4 cells. We've also got an overlap here. Again, this is like the 2 that we just did, right? And this is where I really like the programmer brain, because I know that no matter what we have out here in this tail, they all have to be clean. So we can mark that. That didn't give us too much. So all it did was just take the tail off, right? But we've got an overlap here. So we know there has to be 3 here. There can only be 1 in one of these 2 squares. We know for a fact that these both have to be bombs. And so that solves it and clears it up. And this is where I stopped, and I was like, you know what? It's a good place to stop for the evening. And so, I'm trying to understand what this means. So there's 100 levels to unlock level sets and features, it looks like. And then it looks like there are different grid shapes, right? So the hexagons, and then we saw the squares and the triangles in the beginning. This shows unsolved levels. This way shows bigger grids, and this way shows more complex. Okay, that makes sense. So if we progress down the side, down, we're going to get into bigger and bigger puzzles. If we go from left to right, the puzzles get more and more complicated. And double clicking to test all levels. Okay. Okay. So here we go. It looks like we've got 158 levels to go here. Maybe I didn't solve 100 levels because these all look to be nice round numbers. And it would seem weird that they would start at 258. So maybe we've only solved 42 levels so far. But let's see what we can figure out here, right? We've got some overlap here. I don't know if that's going to give us anything, because we could have 1, 2 here. Let's look at this one and this one. Because there has to be 1 there, which means we know there has to be 1 here within this area here. The yellow. What if we add this in? What does that give us? And this grid gets to be a little bit difficult to read. So here, that one is by itself. We know there has to be one there. We also know that there has to be one there or there. There can't be one in both. But because of this, we know there has to be two along here. But if we, I think what this means is this one has to be clear. But I'm not confident in that. So what I am confident in is that there can only be one bomb here. And let's see if that works. What does that do? If I do this, okay, that rule worked. One thing we could do probably, we could edit that and we could say, hey, it doesn't matter how many there are. If we have a one overlapping, it doesn't matter how many. There can only be one in the remainder, right? Let's update that rule. And let's take a look at this. So there can be one here. There has to be two here. Well, we know with this rule, if there has to be one, well, that doesn't make sense, right? No, it does make sense, right? Let's say that this one is a one. We know that one of these two has to be a one, and so we're overlapping this one, which means that we know we don't care about all of these. They have to be clear. We know that for a fact, and that solves our problem, right? So we're often, I'm looking at this kind of like running our unit tests, right? we're writing our code, and the puzzles that it's solving are kind of like the unit tests, right? We made some fixes to our code, and now it's making sure that our fixes work. Well, this one's interesting. We've got this. We've got this. So we know there has to be one here or here, which means there has to be three bombs here. I feel like I keep creating like these tail rules, and they aren't helpful. But we know that if there's a one overlapping a four with, oh, this is 5. Yeah, okay. So we don't care about the number here. As long as the one is overlapping 2, and we've got 3 others, we know there has to be 3 bombs here. And that solves it. And the reason I went this way instead of putting bombs here is I'm treating it a bit like code, right? And so we've got these rules built up in the beginning, right? 1, 2, and 3. So if there's 3 bombs touching a 3, then we know that, you know, they all have to be bombs. And so using these rules, I think I want to use these rules to do things instead of setting things to bombs. And the main reason for that is that as I was doing it, right, I find that I'm creating more and more tail rules, right? Where something's overlapping something, and then we're taking the tail off. And we may have to keep doing that, and I may be going down a wrong path, but I feel like if we treat these kind of like functions, right? Again, my programmer brain's like, these are kind of like functions, let's reuse them. So with the rule that we just created, right? We just said, hey, if we've got this overlap with a 1, we know that this is a 3 touching 3 bombs. And we know here that we've got a 3 touching 3 bombs. So, this rule then goes into this rule, and I don't have to add a bomb here and keep adding bombs for all of these tail rules. That's my reasoning. We'll see if I'm good, right? So we've got this 5, and we've got a 1 overlapping. This is another tail rule, but it's the inverse of the rule that we just did. So we actually don't care, right? Because we've got a tail here. There could be more 1s coming off. We don't really care about those. We care about the overlap here and here, and we know that there's only 1. We know this has to be a 0. And this again, oh, it doesn't like that. It does not like that. Oh, you know why this doesn't work? Because we aren't forced to have a 1 here. Because of the tail. The tail is wrong. Yeah, that makes sense, right? Because if we had a tail here, we could have a 1 here, and this could be a 0, which means the 1 could be here. With no tail on this, then this becomes this has to be a 0 because these are overlapping 1s. That makes sense. Oh, that's cool. Shows me how many times that rule is hit and how many cells it cleared down here too. Okay. We've got another overlapping 1 here, right? Where we've got 2 1s over the top of 2 1s. This is a tail rule. We don't care here. This just has to be a 0, I think. Yeah. And again, like, I love this because by writing it that way, we're saying, hey, we encountered this rule, but let's reuse our function up above, right? A 0 touching anything is clear. So this one's interesting. So we've got 5. We know there has to be 1 here, so these have to be 0s. That one doesn't work. Oh, the reason this doesn't work is that we're not forcing this to be anything, right? Because if we look, there's still 3 squares, and the 1s could all be in those 3 squares. The thing that makes this logically valid is this 1 here. There can only be 1 here, which means there can only be 1. There can only be 1 here. Means there can only be 1 there, which forces us to have at least 1 here, which now we can say, hey, we don't care, these have to be 0s. Yes, that makes sense. And if you guys have questions, feel free to ask. I'm really enjoying this. It's allowing me to solve programming puzzles, but very graphically. I actually think this would be an amazing tool to teach kids how to think logically and break problems down into step-by-step bites. If you could make this easier to understand, because I think you could get as complicated or as simple as you want. But dang, our rules our rules solved a whole bunch. Again, we've got this one. This doesn't do anything for us because the 3 could be here. There's nothing that forces it here or here. If we add this in, this means that there can be 2 here. How does this work? Because it breaks it apart, but I don't necessarily mean we can guess that there have to be 2 bombs here. Because there could be one here or here. So let's follow this logically. Let's say there's a bomb here. That means there can't be one here or here. So that means there could be a bomb here or here. If there's one here, that means there can't be one here, so there has to be 2 here. If there's one here, that means there can't be one there, there can't be one there. There has to be, if there's one here, there can only be one here. So that doesn't break anything for us. If we put a bomb here, that's the same thing, right? Well, wait, we put one here, which meant there can't be one here. If we put one here, that means that following this, there can't be any bombs here, and there can't be any bombs here, which puts us into a bad state. So we know this one right here can't have bombs in it. So we'll put a 0 there. Is there any, like, if we put one here, that means there's no bombs here or here, which means there's nothing here, but there could be one here or here. And we're in the same state we were here, right? Basically. So really the only place where there has to be 0 bombs is where we put it. And that solves that issue. Man, some of these look crazy as it's overlapping a whole bunch of stuff. But to think that with just 18 rules, we've solved a ton of hex grids. I don't even know how many. But our rules aren't very complicated either. That's the crazy thing about it. Are we going to make it all the way through this first level? Okay, so we did. Interesting. And now we've got 94% of levels. What is this showing? Solved. So 99% pass rate. Does that mean 0.8% of the people who picked up this game? It probably means they couldn't figure out the UI, right? And some people probably brute forced it. But the majority of the people have made it through the first 199 levels? Oh, it starts at level 0. So 95% of people have made it through. We're in the 95th percentile, is basically what this is saying, right? We've made it through, and the same as 94.89% of people, right? 95%. We're in the 95th percentile. We're up there with the majority of people who've picked this up. Most people probably couldn't get through the UI or things like that. That's why I'm betting they... What is robots and clear? I don't know what this means. Maybe we'll learn that later. But now we have a choice. We can go bigger puzzles or we can go wider. And if anybody has strong feelings, I'm willing to go the direction you guys want to go. This is further than I've been before, so I don't know which way gets more difficult. I imagine they both present different challenges. I imagine going this way, we will probably see. So far, we've only ever seen this, right? If we look at our rules, we've only ever seen full numbers, so we haven't seen anything complicated like that. I imagine the difficulty will stay the same going down this way, and so if we go this way, we might pick up some new, difficulty, we could say, meaning we might see like, a 2+ or 1 to 2 or something like that is what I'm guessing. I don't know. And then going down this way, I imagine we'll just see common, solid numbers all the way down. Just the grid gets bigger and bigger. So yeah, if you guys have any desires which way to go, let me know. Otherwise, I think I'm gonna go to the right, and just validate what I'm seeing. I'll give you guys a few minutes if you guys. You know what? We're gonna move on. I think. Yeah, we can just swap at any point in time. It's already solving puzzles. So we're going to go more difficult. And I was right. What are we looking at here? Well, there has to be 0 or fewer here. So if 0 or fewer is touching, and I imagine any number again, we can just say, hey, this is a 0. And that solves that. And then here, if 2+ is in 2 squares, you know what? Let's do functions. I was going to put a bomb there, but I'm doubling down on the functions, right? And this rule is slightly different than this rule. But what this is going to do is it's going to bubble my functions to the top, and then all of my other rules will see like which ones get hit more often. Like this one didn't get hit. How did that not get hit? I'm going to keep an eye on this one. We converted it to a 0, and so, it hit this maybe? I don't know. So this one, we're going to convert it to a 2. So I want to go take a look at that rule. So this one got hit. Oh, this one's been hit 10 times now. And that's what I imagine is going to happen is, our functions are going to slowly bubble up. And then the rest, will be hit. And then I imagine like there's some opportunity to optimize this. So we've got a 3 and a 0 here. And then, this one's probably, I'm not sure how to read this well enough to know, could we take these and put them together because they're all zeros? Put the 0 in the 3, we put the 0 in the question mark, we put the 0. I don't know. I don't know enough to know. Can we optimize that? So here we've got a 1+ by itself, a 1+ touching only ones. Let's just say, hey, you're a 1, buddy. And that solves that. This is interesting because this means there's 1 or fewer, so there could be 0 in here. And this means there has to be at least one. So inside of here, there has to be at least one, but there also has to be one or less. That tells me two things. That means this has to be a 0. That means this also has to be a 1. Let's go with the 1. Because I think that's going to solve a rule. Well, actually, let's test that theory, right? Let's take the 1 out and let's put a 0 here and see what happens. Okay. I don't know why. It'd be nice if you could go back and maybe debug. So here we've got another rule that we know you have to be a 3, right? Because we've got 3 or more bombs touching exactly 3 cells. That has to be a 3. So here, again, we're hitting that same rule from before. Which one was it? Was it this one? Where I put the 0 in? So there are 5 here and 2 here. Here we've got 6 and 2. You know what? This is basically a tail rule. At least that's what I've been calling them, right? If we go take a look at this, it actually doesn't matter how many is here, right? If there's 1 or more overlapping 1 or less in 2 cells, then we know that this one doesn't matter. These all have to be 0s, and it doesn't matter how many of them there are. I think. Oh, yep. That I can hear it going in the background. That solved that issue. And that's again like the programmer, right? And the analyst going on here, right? 3 or more. That means that there could be 4. There has to be at least 3. We also know there has to be a 1 here amongst these 4. What does that tell us? Well, if there's a 1 here or here, then these have to be 0s and we can't hit 3. That means there has to be a 1 here. There absolutely has to be a 1 here. It also means we don't care about the size of the tail. And so the question is, do I put a 1 or a 0? I've been going with 1s, but maybe taking stuff away. Oh, it's a tough call. I put a 0 here. That worked. I don't know which one is better, and that's probably what comes with experience. And this is starting to get a little bit. I mean, we're starting to get pretty complicated here, right? So we've got this one. There has to be at least 3 in these 4 cells, and there has to be at least 2 in these 2 cells. But there's nothing to stop all of them from being filled, and that would satisfy the rule. So this is definitely needed for the logic. So what does that do for us? If I put 1 here, that means this one and this one have to be 0s, which breaks the 2. That means you cannot be a 1. The other thing we know is that you both can't be a 1. And so we know this one has to be a 1. I'm curious, can I say that? Can I say you have to be a 1 and you have to be a 1? It doesn't care. Yeah, that's fine. That didn't do anything for me. What if I edit this rule? We know there has to be 2 bombs across there, but it doesn't like that rule. One thing to note is you can click on this and then so if you click on a rule that you created, you can go here and get into the rule that you created and then just delete it, and then refresh. So we know with this that this has to be a 1 here. A 1 or a 1. So it can't be a 1 by itself. Oh, that's right. This couldn't be a 1. It breaks the rule. This has to be a 0. Right. We know that that has to be a 0. So the rule I created was technically correct because this has to be a 1. And so by connecting this to this, there had to be either a bomb here or here. And that's why it didn't progress the puzzle at all. And so debugging. So if that has to be a 0, is there anything else we can infer? Right? Well, we know that there can only be 1 here. It means there has to be 1 here. I don't know. I don't think we can add anything else to this rule. Yeah, and all that did was remove 1. But we now know that this there has to be 1 here. And we don't care about the size here. We just know there has to be a 1 here. No, we do care about the size. The size is important because only having 1 here is what allows this rule to hit, right? So we're hitting the same spot. Okay, that makes sense. That didn't do anything. Okay, we'll delete that rule. What does this do for us? So here, here, and here. Well, we know that there has to be at least 1 here. So this tail has to be a 0. And we don't care about the size of it either. So that helps. And that made it through. I'm noticing that we're getting some slowdown as we get more rules. And that might be due to the chaining that I'm doing. But, you know, we've had this top rule cleared 993 cells, hit 592 times. That's pretty impressive. Like, is that the biggest clear? By far. That's cool. Okay. So 5 or more touching 5. Well, we know this has to be a 5. And that solves that issue. These get more and more crazy as we go on. Okay, so 4 or more touching 5. These could all be set, so we can't make any inferences about this. There has to be less than 2. That means there could be 0 here. That means there could be 1 here. And that means there could be 2. So that, I mean, 2 there solves it. 1 there solves it. 0 in either of these. Actually, that breaks it, right? Because there has to be 4 or more. So we know this has to at least be a 1. Do we care about the size of the tail? I don't think we do. So if we take that, we know this has to be a 1. Ooh. We don't know that has to be a 1? How is that not the case? How does that work? What did I do that made it different? So, oh, we know there has to be 3 here. We don't know anything about this. There could be 2 here, and that would be perfectly fine. But we know there has to be 3. That's what we know. There has to be a 3 here. We don't know that either. How do we not know that, right? Because we've got 3. Oh, there doesn't have to be 3 here. There could be 2 in here, right? Because it's 4 plus. It's not 5. And there could be 2 here and 2 here, and that would solve it. There could be 2 here, and these could all be set. So that doesn't give us anything either. Let's break it down some more. We know that there can only be 1 here. So this is another one of those tail rules, right? Where we don't care about this, but we do know that this has to be a 1. Yeah. Because we don't care how many there are out here. We just got 2 that at most can be a 1, and this has to have at least one of these full, right? To satisfy the 4 plus. So, and that didn't do anything for us. Did it do anything for us? What if we edit this rule and take out the 1 and put a 0 here? That did something for us. So there has to be at least 4 here. So we know that this is a 4. I was ready to get all complicated and like, oh yeah, this 1 has to be a 1 or a 0 or anything. Sometimes, you know, there's beauty in simplicity. And uh-oh, did we make a mess? There can only be 2 within these 5. I was curious what the 4 is. That's because I've got the 4 there. That's me changing it to a 4. There can only be 2 within this area here. There can also only be 2 within this area. Or within this area. So 2 there, and there has to be 2 there. They could all be here and we would be fine. There could be 1 here and 1 here and 1 here, and there would be fine. we can't have 2 here. There can't be 2 out here. There has to be at least 1 somewhere here and here. And maybe that's the better way to say this, is instead of not 2, we can say there has to be 1. No, we can't say that, because we don't know that. Actually, we do. There can't be exactly 1, there has to be at least 1. You know, learn your programming language and then it works. So, boom, that doesn't do anything. Maybe it does. Maybe we'll be back to that. I don't know. But if we take this and this, we know that this can't be 2. Does that do anything for us? If this can't be 2, this has to be 1, and there has to be 2 or more here. That means this can't be 3, right? Well, let's break it down, right? If we put a 1 here, then this has to be 0. This also has to be 0 here. There has to be 1 there. If we put a 1 there, and this has to be 0. And we can't infer anything from here, so that doesn't work. If we put a 0 here, that means this has to be 1, and this has to be 1. Right? Because we have to get at least 2 here. And if this is 1, that makes this 0, and that 0. So it looks like this rule doesn't help us. Let's get rid of it. If it doesn't help us, we'll get rid of it. So boom, 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 and boom. Let's go big here. We know there has to be at least 1 here. Oh wait, if we know there has to be at least 1 here, we can't infer there has to be 1 there. We also know that there can't be 2 here, here, or here. Let's start. Let's say we put a 1 here, right? That means there has to be a 1 there or there. Does that give us anything? It means there has to be at least a 1 in one of these places. Let's say we put a 1 here. I think this can't be a 1. Because if we put a 1 here, that means we have to put a 0 here. If we put a 0 here, that means we have to put a 1 here and here. But we've already put a 1 here. And so putting a 1 here and here violates there has to be 1 here. I think the rule is this has to be a 0. Okay. A little bit complicated, but and the thing that's crazy about this is I don't think I could play this game the same way every time. So we've got, there has to be at least one here, but there can only be one here, so this has to be one. So this and this means we don't care about this tail, it just has to be a 0. Three and a 1. That's all we get. The most we can have here is 1. But we know there has to be 3. So we know these two have to be 2s. We also know that we don't care about the tail. And we've typically been cutting off the tail. So don't care, you're gone, and that works. And this is another like consistency thing, right? So when we're programming, making sure that we're staying consistent with what we've been doing before, I think is going to work out to our advantage. So here, like we know this has to be a 1 because this can have at most 1. But the other thing we know is that this tail here, we don't care about how long it is. It just has to be 0. And that solves that issue. And you guys can hear the slowdown as it works through the rules when we get a little bit more complicated rules together. I'm really curious, like, what are our top rules? Let's go take a look here, right? Our top rules are, like I was thinking, they're the functions. Our least used rules are turning 5 plus into 4 plus into 4, 5 plus into 5. And then this one, I think this is a tail rule. This is definitely a tail rule. So chopping off these tails, we do quite a bit. Like quite a bit. We can see like the question marks here. I wonder if there's a way in the future to consolidate. Man, that is a super complicated rule. It'll only be hit once. Interesting. Very interesting. I look at what I was just doing there as kind of like profiling my program, right? We're profiling it to make sure that it runs correctly. So here we have, this could be 3 or 4, that's fine. But here, we know this can only be 1. Which means we know there has to be 2 here. Does that do anything for us? Like if I say, hey, there has to be 2 there. That basically solves this one, right? Because we know that has to be gone. Yeah, that solved it all for us. And so we're taking like these bigger problems and breaking them down into smaller problems. And you know, once it gets there, then the computer's like, oh yeah, I can solve this now. I find this fascinating. Person I was watching was comparing it to like chess puzzles, or like the daily Sudoku, right? Where you're not solving the whole, game, or you're not solving the right. We're not solving the whole Sudoku game, or not. Sorry, the whole Minesweeper game. What we're doing is we're taking just a small piece of it, and we're like, can we make this the right decision with this small piece? And in so doing that, does it open something up for us? So we've got 5 here. We also know, so we've got another tail rule going on here. So we're going to treat it like one. consistency again, right? So we know, is that the right way to go, or is the better way to go call this a 4? Because again, we're creating more and more tail rules, or we're just chopping off the tail. I wonder if this is the better way to go. Keep that rule. Here we know we've got 1. And here we don't care about the length of this, which is the tail rule we would have created. Okay, so we've got this and we've got this. We know there has to be at least 1 there, so we know there has to be 1 there, right? Because this is a 2. We know for sure that this has to be 1. And I'm trying to keep the rules small and simple because as we get more complicated, I'm looking at like the number of regions that we join together, kind of like lines of code or code complexity, right? Where the more we join together, the more complex our stuff is and the more difficult it will be to maintain and reason about later on. At least that's what I'm hoping. I don't know if there's like a limit to the number of rules. I'm going to speed this up just a little bit. Well, that was satisfying. Again, we've got 4 touching 5. But we can't make inferences based on this. We're going to have to link them all together. So we know in this case that this has to be 3. There's no way around it, right? Because there can be 1 or 2 here. Well, if there's 2 here, that doesn't have to be 3. What would force this? What are we forcing here? Like there could be 2 here. We have to make sure that there can only be 1 here. So we know that there has to be 1 here and at most 1 here, but there could be 0. So if we put a 1 here, there's a 0 here. So putting a 1 here, puts a 0 here, which forces these to all be, that means this has to be, this breaks, right? If we put a 1 here. So we know there has to be a 0 in this cell. If we put a 1 here, this has to be a 0 and a 0 and a 0 and a 0, and that still works. The only place where it has to be a 0 is here, I think. Yeah. I turned it up quite a bit. Let's drop it down just a little bit. So we've got, there has to be a 1 here and at least 2 here. Well, we know in this case that this tail can be taken off. So let's do that. And I know I keep saying, hey, we're not going to create more tail rules, and then I go create more tail rules. Because again, here's another tail rule, right? This one and this one. We don't care about the length of this. We just know it has to be a 0. And this is like where you're learning your framework or your programming language, right? A lot of times you'll just keep doing things differently every time because you're not really certain what's right. But something that solves something is better than something that doesn't? How does this work? What is this red line? This red line is saying what? If we put a 1 here, that has to be a 0. Which means that has to be a 1 and that has to be a 0. That means these two can't be the same. That's what that red line means, but how would we add that red line? This is interesting. So in this rule right here, we know this one can't be a 1. Right? Because if we put a 1 here, that means this has to be a 0 and this has to be a 0, because you know we can't have more than 1. And if this is a 0 and this is a 0, then that then we can't make 2 for this area. So we know for a fact this has to be a 0. And what did I unlock? So we finished that. Score wise, okay. We're looking at Steam users. That's good. I've scored 402. The question is, do we go more complicated or do we go bigger? Bigger. Sounds good. We're going bigger. We're probably going to rip through all of this. Because we've solved a whole bunch of complicated rules, right? We've got 41 rules. I'm really curious what is our most... That is so satisfying. It's like watching your unit tests all pass. That's kind of the way it feels. If unit tested pops and dings, it'd be more You know what? I wonder if you could write a Jest plugin that would do pops and dings. That would be amazing. So we know there has to be 1 here. You know, there has to be 1 here. We can't make any inferences because 1 could be anywhere. But what we can infer is that there's 2 across here. If we put a 1 here, that means 0 and 0. So that doesn't work. This can't be a 1. This can be a 1 and this can be a 1. And those are the only inferences we could make. So this for sure has to be a 0. Helps we don't have to mock services and deal with Cypress component. Yeah, exactly. Totally true. But I think, like, the reason I like games like these is they force me to think logically, and that keeps my brain sharp, right? This one is interesting. We know here and here we kind of have a tail rule, right? We know there has to be 1 here and here. I think that is this. So we could say for sure we don't care about this and this, and they both have to be zeros? No. Why can't we say that? We know there has to be 1 there. We also know there has to be 0 there, right? Because if there's a 1 here, then there's 0, 0. Like, we know there has to be a 1 in these 2 squares. Um, we say 0 and 0? No. The only thing we know is that there has to be a 1 there. If there's a 1 there, 0, 0. I guess that's true. We can't make this inference. But yeah, if you like games plus testing, I bet you enjoy the Friday Facts blog. Oh yeah, I love the Friday Facts blog by Factorio. Yeah, that one was so good where they were talking about E2E and spinning up things and making their factories deterministic. That was so good. And yeah, there's a reason this rule doesn't work. I'm making too many inferences here. So let's take a look. This one, there has to be 2. There has to be 1. And this one also has to have 1. So if we get 1 and 1 here, that means you have to be a 0, which means we could put a 1 there. So that doesn't help either. Oh man, that grid. What do we know? Well, we know there has to be 2 in this red block here. So can we make any determinations from here? If there's a 1 here, that means you or you have to be a 1. There's no determinations we can make there, really. Let's start down here. If there's a 1 here, that means that you have to be a 0, you have to be a 0. No, you don't have to be a 0. You have to be a 0, you have to be a 0, and you have to be a 0. In that case, that forces both of you to be 1s, which also forces you to be a 0, which we already knew. And it also forces you to be a 1. That doesn't break anything. So my guess, like, I'm going by programmer gut instinct here, right? When something needs to break, always look at the thing that has to break, or the most complicated, right? If I put a 1 here, what does that force? If I put a 1 here, that means you have to be 0 and you have to be 0. That doesn't break anything. It also means that you have to be 0, you have to be 0, and you have to be 0. If you have to be 0, that means you have to be 1. Or you have to be 1. And you could be 0. That doesn't break anything. Right? Because you can be a 0. Which that makes you 1 and 1. You're a 1, then you have to be a 0. But we already have a 1 here. Just make some. So we're going to make some markings here so that we know what we've got, right? The you two have to be 1s. We already said you were a 0. Oh, I can't do that. Darn it. It all has to be done in my head or on paper. What if I make you a 1? I think we're too broken up here. I think we want this and this. that doesn't do anything for us without this, right? Because that creates the chain that goes from here to here to here to right. So that allows all of this. In this chain, what do we know? Again, let's go here where things are the most complicated and just start with a 1 or a 0. So we make you a 1. That basically means you have to be a 0. If you're a 0, you have to be a 1, and you can be a 0. That's fine. If we make... No. Yeah, if we make you a 0, that means you and you have to be 1s. Which means you have to be a 1, and you guys have to be 0s. Regardless of what we do, I think you have to... No, you don't have to be 0s. So there's nothing here that breaks things down for us. Makes me wonder if my rules are working against us here. Is there some rule we can infer out of this? I think this is necessary. Even though it's breaking it down too much, if we make you a 1, you guys have to be 0. Which means you have to be 1, which means you have to be 1. So you have to be 0. So you have to be 1. So 1, 1, 0, 0, 0, 0, 1, 0. Oh wait. 1, 1. And these all have to be 0s. 1 and 1. Right? Because these are 0s. That doesn't break anything. One and 1 makes you 0. It also makes you 0. That was basically just me going backwards. 0, 1, and 1. You go 0, 1, and 1. Then you're a 1, and 0's all the way down. You're a 1, 0's all the way down. And 0, 1, and 1. Boom. 1 and 1. So if we make these two 1 and 1, that means 0, but we can't have two 0s here. That's where we can break it. 1 and 1, 0, and that would give us 0 and 0. We don't need to make the rules so complicated. This, and this breaks it. 1 and 1, we know we can't do that. So we know we have to have 1 here, right? 1 and 1 has to be here. If this isn't a 0, well, if this is a 1 and 1, 1 and 1, 0, 1, yeah. But 1 and 1 can't be here. What does that tell us, right? So if I put a 1 here, that means we can't have a 1 here. Means there has to be a 1 here and here? No. Will we put a 0 and a 1 here and here? Well, that doesn't give us anything. We know there can't be a 1 and 1 here. That forces a 0 and a 0. What that means is we can't have zeros here. But we know that because we've got a 1 here. Minecraft has some UE ones, but it is way more costly and at times non-deterministic. Oh, that's cool. I have to take a look at the Minecraft ones too. Yeah, well, I think the reason Minecraft can't be deterministic is because of the level of randomness, right? So it's this cycle right here where these can't be the same, really. Right? Well, they can, right? 1 and 1 is the same, right? It's this one can't be the same as this one. Does that mean we always have to have a 1 here? If we don't put a 1 here, puts a 1 here, which puts a 0 here. Does that mean we can't have a 0 here? If we can't put a 0 here, that puts a 1 here. Puts a 0 here, and that breaks things. This can't be a 0. This has to be a 1. Did I already try that before? I feel like I'm going a bit in circles here. No, I didn't. Yes, that has to be a 1. Does that solve? That does solve our thing. Ah. More logic. So we've got some overlap here, right? Where there has to be 2 inside of here. Oh, these don't touch. For whatever reason, I thought this was there, but I've already got a rule created around that. It looks like we probably need these 3. So in this case, what if I put a 1 and a 1 here? Right? And this was a 0. So if this were 1 and 1, that would mean zeros here and zeros there, and that's fine. If I put a 1 here and a 1 here, that means you're 0. You're zeros, and we're still fine. If I put a 1 here, and so we went here, right? 1 and 1, which makes you 0, 0, and you 0 and 0, 0. That's fine, right? What would break this? We had a 1 here and a 1 here. You would have to be a 1 and a bunch of zeros here. You would have to be zeros, but you could be a 1 and zeros. What if I put a 1 here? Put zeros all the way around here? Right? which makes U a 0, which means 1 and 1, 0, 0. What if I put a 1 here? U can't be a 1. You have to be a 0 here. So the blue and light blue, where they intersect, has to be a 0. This has to be a 0. And that's kind of the zen of this game, right? So we've got, there have to be 3 within 5. There also has to be 1 here and 1 here. This one doesn't affect anything. So within this, so we've got 3 regions. With this, we know this has to be a 1. If that has to be a 1, actually the other thing we know is that we don't care about the length of the tails. There's a tail and there's a tail, and we also know that these are zeros, right? We don't care about the length of those tails. Yeah, cutting off those tails helped us. Interesting. Oh, I was like, oh crap, this is going to be difficult. No, it's not. This is easy. This is just a 6. One equals 1. Yeah, oh. Yeah, I can't simplify more than that. This is a bomb rule. We're actually creating a bomb rule. And we leveled up again. What do we get? We got squares. Interesting. We've got this. And we've basically got this triangle here. Right? So with this triangle, we know that we have to have 1 somewhere here, which means we know these have to be 2s. We also know this tail here doesn't matter and can be a 0. We don't know that. So I guess we have to dig deeper, right? Can we just say, hey, this has to be a 2? Nope, we don't know that either. If we make this a 1, these have to be 0s and 0, 0 and 0. That's the rule. This right here has to be a 0. That's all we know. Do we care about the length of the tail? No, we don't. And like doing this, there's so many comparisons to programming doing this, but like adding the question mark here, I do this all the time, right? Can I write this statement this way in the programming language? Oh, the compiler hates it. Let's stop, right? Oh, that worked. Okay, let's go. Let's keep going. So this is really the piece that we need to figure out, right? And it's tied across this. So now we know there has to be 1 here or here. Do we know that? No, we don't know that yet. We do know that now, right? 1 there, 1 there, or there. Yes, there has to be, right? And I'm beginning to get better at reading these. So when I was in college, I was studying to be an electrical engineer before I found a job that forced me to quit. Truth tables, right? So what you would do is you draw out all these T's and truths and falses, right? And then you could draw squares around them. What I know is that we've got two areas here. And these two areas have to have 1 in them. There has to be. What that tells me is that this has to be a 0, and this has to be a 0, I think. So let's see if I'm getting better. I am getting better. I also think we don't care about the length here, and we don't care about the length here. Absolutely not. So very, very much like truth tables. If you guys have ever done truth tables and ever simplified truth tables, this is bringing back those memories to me. I can look within this box and see, oh, we can make inferences, logical inferences based on how this is grouped, which is awesome. I love it. This scratches so many programmer itches. It's amazing. So I'm really curious. Very, very, very curious. How much more difficult are squares? Oh, wow. Look at this chain. We've basically got a cycle going on here, right? So we've got this. This doesn't help us. So adding this is just going to get us distracted. This does help us. This does, and this does. So this is the most we can have. If I look, we've got 3 regions here. There has to be a 1 here, and here it says. Is that what that's saying? No, there could be 2 here, and there could be a 1 here or here. But if we looked at the help, and I don't know what this means. I can't see any way to draw this, but it's kind of showing us that, hey, in a cycle like this, where there's an even number of nodes, these two can't be the same, I think is what it's showing us. So if we look, we've got 1, 2, 3, 4, 5, 6, 7. We've got an odd number of nodes. If I put a 1 here, this has to be a 0. Which means these all have to be 1s. Which means that has to be a 0. And that has to be a 1. So yeah, these are the same. Which we know. No, that breaks it. That absolutely breaks it. But how? Right? These can't be the same. So a 1 here, 0, 1, 2, 3. A 1 here puts a 0 here. What would we do to kind of break this? 1, 2, 3, 4, 5. Same number of nodes. That adds 6. That could do it. We did this, 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 and that? Wait, how did I get the 3 in there? I wanted this one, I wanted this one, I wanted this one, I wanted this one, and I wanted this one. Right? And so that means that that one and that one can't be the same. Is that true? 1, 0, 1, 0, 1, 0. Yes, that does mean that these two can't be the same. So 1, 0 would put a 0 here, which means that that can't happen, but we don't know that because we don't have the 3 in place. right? These two can't be the same. How do we, well, can we do it this way? Can I add a rule and just say, hey, this one and this one have to be a 1? Between those two, there has to be a 1 there. No, there doesn't. Just in this cycle, right? 0, 1, 0, 1, 0, 1. Then it's possible. In this cycle, this has to be a 0, but we don't know that. We can't prove that without this piece here. So this piece is the key to unlocking this. We need this piece. So we know you have to be a 0. Which 1, 1, 1, right? But all that does is just tell us this has to be a 0 or a 2. But we don't know that either. So what if we add this piece in and this piece in? What does that give us? So now if we go 0, 1, 1, 1, 0 doesn't do us any good. Doesn't do us any good. In this case, we know that these two can't be the same. This one and this. No, I did the wrong one. Which one is it? This one? Is this not in here? Boom, boom, boom. Oh. Wait, what did I do wrong? Wasn't I able to get that in there before? You, and you. Oh. 1, 2, 3, 4, 5. I can't get the 6th one in there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Does that work? You, and you. So here we know you, like if you're a 1, you're a 0, which means 1, 2, 3, you're a 0. Yes, in this case, we know that here and where is it? Be off by itself. You and you have to be a 1. There has to be a 1 between the two of you. That doesn't have to be the case. You have to be a 0 or a 1. Does that give us anything? Oh. Now we've got some better cycles going on. Now if we take this, 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 and this, we can make some inferences, right? So where's our most complicated area? Here. If we put a 1 here, that means that you have to be a 0, right? You have to be a 0, which forces you to be a 1. and it forces you two to be ones because you have to be a 0. And that's fine. That cycle works. What if we run it the opposite way and go in reverse? If we put a 0 here, then we have to follow this one. This has to be a 1. If you're a 1, that means we have to have what if you are a 1? If you're a 1, it means you have to be a 0. If you're a 0, that doesn't mean anything here. Doesn't mean anything here. Not really. This one doesn't work. So what about this one, this one, this one, and this one? And again, starting in where the most overlaps happen. So here, if you're a 1, it doesn't mean anything. Because you can be a 1, and you could easily be a 1, and we'd be fine, right? The 0 and 0. The 0 and 1s I don't think help us. Interesting. So 1, 2, 3, 4, 5, right? Boom, 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 boom. How big is, so 1, 2, 3. So it's n plus 1, right? So if I pick any 3, we've got 4, right? 1, 2, 3, 4. So these two can't be the same. These two can't be the same. Boom, boom, boom. Is it the same here? Can I say that like this one plus this one plus this one, 1, 2, 3, 4, 5, 6, these two can't be the same. Why didn't that work? You, and you and you can't be the same, right? 1, 0, 1, 2, 3, 0. Yeah. But we already had that before. And that's basically this one and this one. And this, is it this one and this one? Would that give us anything? We went here, here, and here. We know you have to be a 0. I just don't know how to. With only 4 connections, you know, that's kind of the puzzle that we're in. I think it has, I mean, I think the key has to be here. 1, 0, 1, and then there has to be 2 somewhere here, and then could be a 1 and a 0 here. That doesn't matter. I'm ready for a hint. What is that telling me? The cycle we started out first. Is that the cycle? 1, 2, 3, 4, 5, 6. Is that one represented there? It is. That one is. That one is, and that one is. So we know this one's a red herring. Is basically what it's telling us. Which I thought from the beginning, but I don't know, like, maybe this is the problem? Like if we go here, 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 and here? Red hair. Yeah, Scooby-Doo. You are old school, my friend, if you remember Scooby-Doo. Much like me. Boom, boom, boom. So 1, 0, 1, 0, 1. What is this telling me? There has to be 3 within 4. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, or 1, 2, 3. Right, there are 4 ways to pick 4, choose 3. There are 4 ways to do that. If we add U, now we've broken you down to there has to be 1 here. Is that what it means? No. It doesn't mean that because just because we've done that doesn't give us anything. I was going to say, put a question mark there. That's what I would do. And then work backwards from there. So here, these are all touching 1. It's a big number of 1s here. I don't think this one matters because it only touches these right here. That one touches that. This one, what is it touching? A whole bunch of things. That one only touches that. That one only touches that. That one only touches 1, 2, 3. So these 3 and that one. Get you. Let's get you. Let's get you. One, 2, 3, 4. Which means if we go odd, then we have to go like 1, 0, 1, 0. 1, 0, 1, 0. If we grab that one, does it give us any? if we follow that same chain, 1, you have to be a 0. 1 or 1 0 1 0. These two have to be the same, right? That doesn't give us anything. I think it has to do with these 3 1s right here. Maybe that. Ooh. Ooh. Look at that. Now we've got 3 by themselves. Let's say all 3 of these are 1s. What does that mean for us? It means you have to be a 0, which means you have to be a 1. It means you have to be a 0, which means you have to be a 1. That's fine. What if you're a 1, 0, 1, 0, and then 2 there? Is that what that means? That we can get like a 2 or a 3 here? Does that give us anything? Much smaller. Take that and we take that. Does that mean you have to be a 2 now? No. Hey, Louis 2. Welcome to the stream. Just trying to solve a logic puzzle here. It's basically Minesweeper. But we don't have any mines that are visible yet. And we're trying to break this puzzle down into something useful. Does that give us like... No, it just removed the rules that I did. So that tells me that the rules that I added were garbage rules. They don't do anything for us. So you touch that, that's 1, 2, 3, 4. But using only these doesn't help. I don't think. 1 0 1 0 1. These have to be the same. If I add that this has to be a 0 or a 1 here, which one is that one? You have to be a 0 or a 1, and you have to be a 0 or a 1. And it doesn't care. It's saying that's illogical. I disagree. I disagree. I guess technically, it's right. It's right. This has to be a 0 or a 2. Boom. And now we're back to where we were before. If we know this has to be a 2 or a 3, and this has to be a 2 or a 3, oh wait, this changes things. We know this probably has to be a 2 now, right? Because this can't be a 0. That definitely changed things. Yeah. Oh my goodness, that took a while. So this is the same stuff we were looking at, but probably because I went backwards. What is it wanting me to look at here? Oh, it's wanting me to run all the tests. Okay, we're running unit tests again. I totally agree with the dings and the pops. Yo, the thumbnail, saw the thumbnail and had to see what's going on here. Some 40 chess version of Minesweeper. So it's crazy, Josh. This game, it's called Bombe. It's Bombe. And it's like programming. So like you come in here and you build these rules. And like right now I've got them sorted. So this rule right here basically says I don't care what it is. If it's touching a 0, it's empty. And so this is telling me how many times this rule's been hit and how many cells have been cleared. This rule right here says, hey, if there can only be one bomb and it's, you know, touching a 1, then it's a bomb, right? Same here, 2 and 2, same thing. This one says, hey, if it says it's 0 or less, it's really a 0, right? This one 3 and 3, and so we're basically like these ones I'm looking at is like functions, and then we get into more complicated things here, where we're saying, hey, there has to be 5 within these 6 cells here, right? There has to be 4 here, which means there has to be 1 within however many cells are here. So these 2 have to be 1. This has to be 4. So we're gonna cut the tail off. We don't care. Exactly, Michael. Got tired of coding. No, I'm actually getting back into coding a little bit later here. I was like, if I'm gonna be writing code later tonight, I just want to take a break and go do something. And this looked amazing. And so it is kind of like 4D chess. So it's automating Minesweeper through logical rules. And we're kind of solving like, the daily chess, the daily chess puzzle. But we're doing it for Minesweeper on a hex grid. The next one we could do is we could move over to like a square grid. I actually wanted to take a look at that and see if it got more difficult. But the cool thing about this is like, we can run things slower so we can see how the rules are hitting, and if they're not, and things like that. I've got it turned up because I wanted to make it through levels, and make it to the actual fun stuff, right? Instead of just watching things. Michael kind of was like, you know what? Yeah. Exactly. It scratches like a programmer itch that I have, right? Like Factorio is a big one for me because of that. Like optimization and logic and just logic puzzles. Usually when I'm playing games, I won't say usually, like, over the weekend I played Baldur's Gate. I'm trying to finish that game up. But a lot of times I am playing things like Sudoku or like the new Shapes game is a lot of fun because it's just optimization. It's like the stuff that I know. Yeah, this guy Factorios. Exactly. This guy does Factorio. Josh has a video on Factorio in relationship to observable streams if you have it. Oh, really? I have not seen your Factorio stream. Observable Factorio stuff. I'm gonna go look that up. That sounds amazing. Oh, dude. We solved all of... Why did we skip like these 9? Because it can't solve them. That's why. Double clicking is just going to keep running it. I'm curious about squares. So a lot of our rules work for squares, but this one doesn't. What's going on here? So we have 4 squares, there have to be 3. Here we've got 3 there. So the overlap is here. There have to be 3 in here, which means we don't care how big this is. It has to be 0. And that's the way the rules work on this one. It's an old one, but it checks out. And as soon as he said that you've got Factorio and RxJS streams, they make perfect sense together. I actually thought about using like a form of observables to create a mod for Factorio, because you can read belts and do all sorts of cool stuff, right? So within these 4, there has to be 2. That means, again, we don't care how big this is. It has to be 0. So, oh, interesting. Now we've got an interesting one. Because there can only be 1 across these 3, so we know these 2 have to be a 2. But we also know we don't care about this tail. And this is the thing we've been doing, right? Is cutting off the tails. Again, consistency. I broke the consistency and we ran into some weird puzzles. And it's crazy how fast this goes. So here there has to be 3. And here there has to be 2. So over here we know that this has to be 1. And we don't care about the size either. We just know it has to be 1. Squares are easier. I'm going to say that and regret it, but... So we've got 4 here. We've got 2s here. So there's total overlap here, right? If we're reading our truth table here, we know that all of our 2s have to be here. There's nothing here. So that means the remaining 1, or there has to be 2 here, which means there also has to be 2 here. We don't care how big this is. This just has to be 2. And that's the power. Like, this is why this game appealed to me so much as I was watching somebody play it on YouTube. This is very much, I mean, first of all, the music's very zen, right? And I don't know if I'm going to get a copyright strike or not on YouTube. I'm going to have to decide if I'm going to publish this or not. But man, this is so good. We know there has to be 2, so within here there has to be 4. There has to be 2 across here, but there has to be 4. We know this has to be 1. No, actually we know this has to be 2. And the reason we know that is there has to be 4 here. If this was 1, that would have to put a 3 here, which would violate the 2s. So we know that this has to be 2. I think we also don't care about the size. We just care that it's a 2. No, it has to be 2. Okay. That's fair. Yeah, I just downloaded a demo to try the game. The interface is a little bit difficult to overcome. So if you have questions, reach out. It's a lot of fun. We know there has to be 2 here. So across these 2, we know we don't care about the size of the tail. We just chop it off. So there we go. I think I'm going to go back to the hexes. What I want to do is try and make it all the way to the bottom of the hexes here, or all the way across the top, and see if we can solve a lot of our rules that way. So we know there has to be 4 across these 6. We've also got an overlap here with a 1. So there has to be either a 1 here. So 4, that doesn't help us. Because there could be 4 here, and the 1 could be here. So that definitely doesn't help us. So let's grab this one right here. And now we know 3, so there has to be 1 somewhere. We also know that there has to be 1 here. So I think we can say that these 2 have to be zeros. No, we can't say that. So there has to be 3 here, right? Well, there could be 1, 2, 3, and then 1 here. No, there can't be. This one has to have 1 in it. And we're overlapping 2. Which is why I think we can cut off this tail. But do we know anything about this? Like, there has to be 1 here. Maybe there has to be 1 across all of this. Can that be a 0? No. What am I missing? Let's undo this and let's look at this one and this one because they look like they overlap, right? Boom and boom. But we could have a 1 here, we could have a 1 here. This one doesn't do anything for us, I don't think. Yeah, because we could have a 1 here or here. Does that do something for us? If we have a 1 here, that means we have to have a 0 here. If we have a 0 here, we could have a 1 here, and that would satisfy both of these. That doesn't do anything. If we have a 0 here, we have to have a 1 here. That 1 means I have to have a 0 here. I could have zeros here and here, and we would still be fine. So there's nothing beneficial here. So it has to be the interaction between these. So across here, we have to have 1, which we know. I mean, that's just a given. And then here we have to have 1. I mean, that means that we're more likely to need a 1 here. And less likely to need 1 here or here. Right? Does that mean this has to be a 3? No, it doesn't. What does this mean? Because we've got 4 and we need 3. We could have 1s in all of these, but we can't have 1s here. This has to be a 1, right? In the case that this is a 0, so this can't be a 0 is really what we can say. This one can't be a 0, and that's good. And then in that case, this one or that one could be a 1, and that's fine. That one or that one could be a 1. No, they can't. I think the only thing we can infer is that this can't be a 0. And that doesn't give us anything, does it? I don't think it does. Time for a hint. The hint is here. There's only 2 that touch here. But to get that, we have to do that. And the hint is that it has to do with this block. If this block is a 1, this block has to be a 0, this block has to be a 0, this block has to be a 0. So if this block is a 1, these all have to be zeros. Right? Same here, these all have to be zeros. If this block is a 0, what do we know? Really nothing. Right? Because if this is a 0, that means one of these has to be a 1, and one of these has to be a 1. Does that break anything? This could potentially break, right? Because this one could easily be a 1. If this block is a 0, then we know one of these has to be a 1, right? We also know that we've got 6 blocks where we can have a 4, like a bomb, right? 4 bombs. That means that 2 of them have to be empty. Oh, that does mean something here. That definitely means that definitely does mean something here, right? Because if this is a 1, then this has to be a 0 and this has to be a 0. Right? And if this is a 1, this has to be a 0 and that has to be a 0. That means that we've only got 3 blocks to create 4 with. That means this absolutely has to be a 0. And that's what we know. And sometimes we need to ask for help, right? Man, that one was crazy. Oh, wow. Like, sometimes this stuff is difficult to read, but if we look, we've got a 2 here and a 1 here. That means we could have 2 there, but if we have a 1 there and a 2 there, we're still okay. If we go here and we add this, those are not the ones we wanted to add. We want this one. So now we know we could have a 2 there or a 2 there. I think we want this one too, because that breaks this 2 into 2 regions. So we know we have to have, well, we could have a 2 there. If we have 2 there, that means this has to be 0. And that can be 2. That's fine. If we have 1 there, it means we have to have 1 there, which means we have to have 1 there, which means we have to have 1 there, right? And maybe the 1 is the wrong thing to be adding. This one, this one, this one. 1, 1, 1, 1, and that all works. So this definitely is what changes it. The monthly Angular stream with Mark and Jeremy is this Friday. Yeah, it is. And there will be some good stuff. See, 111, that's fine. However, 2, 2, 2 and 2 works, right? In this case, we could have 2 here and 2 here. Oh, no, we can't. We can't. There has to be 1 and 1 here. Absolutely has to be 1 and 1 here. And we know that because this one. We could probably break this down, right? This, and this. There has to be, like, we can't put 2 here and 2 here. That doesn't work because this 2 would break down. It would have 4, right? So there has to be 1 here and 1 here, which means we know this one has to be a 1. We also know this one has to be a 1. We also don't care about the length on this one. It just has to be a 1. Wrong. We care about the length, I guess. It doesn't have to be a 1. Okay. Why doesn't that have to be 1? This one for sure has to be a 1. No. Why doesn't it have to be a 1? If I put 2 here, oh, it's this that makes it, it's this. This forces this to be a 1. And this is where we don't care now. We can say it has to be a 1. Yes. And the reason that this forces it is that we could absolutely have this be a 2 and this be a 2, and that would be fine, right? These could be zeros and they would be fine. But as soon as we say there can only be 1 within this space, this forces this to be a 1, and that's the logical rule. It does some curse convention that nobody else does. I love Jeremy. Yeah, he absolutely. Holy cow! I'm looking at this going, what did I get into? There's 6 across here, right? But there has to be 1 there, which means this has to be a 4, and we don't care about this. That's kind of the programmer stuff, right? Like we built up the rules, and so as soon as we made that one a 4, it triggered this rule. And as soon as it put 4 bombs down, it was able to make other decisions. That's what I'm loving about what we're doing right now. So this is a 2. We need to break it up, right? We've got this one and this one. And so this 2 now has to have, it's broken up, right? And across here, we can only have 1 also. And inside of here, boom. So the only way for this to have 1 in it is if this is a 0 and this is a 0. So if we assume this is a 0, that means these 2 are 1s. Right? And that means that we have to have a 1 across there. So that works because that can still be a 0 and that can be a 0. That definitely works. For this to be a 0, that means we have to have a 1 here or a 1 here. If we put a 1 here, that means these have to be 0s. And since we put a 1 here, that has to be a 0. And that can't be the case. This has to be a 0. Man, these are getting complicated. Ooh, I'm going way over. I need to get... I'm gonna have to stop. Thank you guys for hanging out with me. Just while we played some quick games. It's not something I do very often, right? Like around Christmas time, we played 7 million people. This one was a lot of fun. I really enjoyed this, and it's difficult for me to even want to stop right now. Thank you for joining, Michael. It was a lot of fun. And Louis, you're gonna have to tell me if Louis F. You're gonna have to tell me what you thought of the demo. I downloaded the demo, tried it, and then wound up buying the game for $10. And then had to go look up how to reset my progress so that we could start from the beginning. Made it through like 100 levels and was like, yeah, this is something for me. You guys definitely have a good evening. We'll be back on Thursday. We're going to be doing some streaming. And, well, of course we're going to be doing some streaming. But I've got some ideas. The optimization stuff went so easy and fast that I've had to think up some ideas. I've got some ideas for what I want to do. I want to get them set up, and then we'll talk about them. But you guys have the demo is very cool to start. Yeah, the demo is really good, and like this isn't a game for everybody, right? If we look, we're now in the 63rd percentile. So like. Look at the drop here from 72 to 63. Oh, so, okay, I get it. So, most of the levels we've solved, people have figured out. Oh, in these 200... Oh, so if I click on this, okay, it's not like globally, it's like 93% of people have 90x% of people have solved this, right? But, once we get here, we're now in a much more, like this puzzle that I'm looking at right now, only 63% of the people have solved. Well, let's help 37% of the people, right? Let's solve it, and then I'll call it a night. My goodness. Oh, wow. So we've got 3 here and 3 here, which means all 3 could be here, but they can't be here. There has to be 2 or 2 here, which means that this can't be 3. That doesn't help us. We've got that one. We've got that one. This one overlaps. That's a big help, right? Because now we've got 4 regions where only 3 can fit. 3 can't sit here. This can't be 3. Could 2 sit in here theoretically? Maybe. No, 2 cannot sit in here. This has to be a 1, and there has to be 1 across these 2. Which means across these 2 there has to be 1. Right? No, these 2 both have to be... I think we can say that this has to be 2 here and here. Undo that and put the 2 there. No, we can't say that. We know for sure that within here, if these are zeros, there has to be at least 1 in here. So we can say that there has to be 1 here. Is that true? Obviously it's not. But why isn't that true? Boom, boom. So within here, there has to be 3. There could be 2 here, which would make it 0 out here. So there has to be 1 or 2 here. That's what there has to be, 1 or 2. That has to be true. Now if we build our rule around this, what has to be true? Well, this one has to have 1 or 2 here, which means there has to be 1 or 2 here. What does that mean about this? Nothing. What does that mean about this? Nothing. Try and solve the game with streams that actually make you think are rare. I hope you get more viewers. Thank you very much for that, Louis F. I typically stream Angular stuff, and that's kind of a niche market. And in fact, right now in the chat, Josh Maroney is probably one of the bigger Angular YouTubers out there. You should definitely go check him out. And thank you for the compliment. I hope I do too. I enjoy, I don't want to get on and just, I don't know, maybe someday we'll just get on and play a game and just be silly, right? But most of the time I'm always looking to learn. I don't know that I'm going to solve this one. I think I need to call it an evening. Thank you guys very much for joining me. We'll see you guys all on Thursday. You guys all have a great evening.